So this question is about some gases present in air, which is the most common gas in the dry air. So most common means, most common gas is the one which is in the higher percentage in an air. So obviously this would be nitrogen, right? This would be nitrogen. And they
Yes.
are asking in B, which gas makes up about 1% of dry air. 1%. I think so. This is the question that is the repeated question we were doing yesterday. It was argon. Am I right?
Yeah.
Exactly. A piece of copper is heated in air. State the formula and color of the compound formed. So copper means that is Cu, okay, and it's going to react with oxygen. They are saying heated in air means it's going to react with oxygen. So obviously it would be forming oxide of copper, that is CuO. So ultimately the formula would be CuO, and the color of the oxide would be. Can you tell me the color?
Like brownish, blackish.
Uh, exactly, yes. Black color. It has a black color, right?
Yeah.
It has a black color. So this is black. Copper oxide is black. Okay, now the diagram shows apparatus that can be used to prepare carbon dioxide in the laboratory. The liquid in the tap funnel is calcium chloride solution, concentrated sulfuric acid, dilute hydrochloric acid, or hydrogen peroxide solution. What do you think?
Hydrogen. The
Hmm?
liquid funnel is uh I'm not really sure. Sorry, I'm not sure.
Okay, basically, you have to prepare carbon dioxide. Carbon dioxide is always released from the carbonate, and carbonate reacts with an acid. Remember, carbonate reacts with an acid. Okay, carbonate reacts with an acid. So ultimately there would be hydrochloric acid. There would be hydrochloric acid, right? There would be hydrochloric acid. Okay.
Okay.
Yes, when hydrochloric acid reacts with carbonate, so it releases carbon dioxide. The solid in the conical flask is obviously the solid contain should contain carbonate. You have to select the one option in which you can see the carbonate, in which you can see the carbonate. Obviously, it would be A. Am I right?
Yeah.
Exactly. The diagram shows the gas being collected over water. Suggest another way to collect the gas. Suggest another way to collect the gas. So oxygen is heavier than air or the lighter than air? What do you think? Carbon dioxide. Allah Akbar, Allah Akbar. Wait, Azan.
Okay.
Allah Akbar. Okay, so yes, what do you think? Carbon dioxide is heavier than air or lighter than air, so that we may decide that which should be the which should be another method to
Uh,
collect the gas. It's heavier than air, right? Because the mass for carbon dioxide is more than air.
yeah.
It's 44. So you can write that, okay, we can collect the gas by downward delivery in air. By downward delivery in air.
Okay.
Downward delivery in air.
Okay.
Downward delivery.
Okay.
Exactly. So lime water can be used in a test for carbon dioxide. Lime water is calcium hydroxide. Complete this equation by inserting state samples for the reaction used to test for carbon dioxide. So state sample we have to write. State samples. Carbon dioxide is
Um, Carbon dioxide is like is what?
is what? Solid liquid gas.
Oh, gas.
Hmm. Then
Then carbon di that's also carbon that's OH too. So that's water, isn't it? Liquid?
it's aqueous. Liquid is water, okay?
Okay.
Liquid is water. And obviously, calcium hydroxide is soluble in water, so that's why we are saying that this is aqueous. It's lime water. It's dissolved in water. It's soluble in water. Calcium carbonate is solid,
Okay.
and H2O is liquid. State the observation made in this test. You have added lime water to check carbon dioxide. If the carbon dioxide is present, if the carbon dioxide is present, so what would you see in your container, in your beaker, or in your test tube?
Um, can you repeat that, sir? Sorry, I couldn't hear you well. The voice.
Oh, they are asking what you would observe if you are going to do the test for the carbon dioxide. What would you observe?
Um, Making the test. Oh, the lime water would turn milky, wouldn't it?
Exactly, exactly. The lime water would turn milky. So if they turn milky, so you can say the carbon dioxide is confirmed. Lime water turns milky.
Mm-hmm.
See this. Question number two. You can see this. I'm going to share my screen. In this way, you can check the presence for carbon dioxide. Can you see my screen?
Yeah.
And this is the test for carbon dioxide. We need some lime water in a test tube, and the source of carbon dioxide that I'm going to use today is me. So I have a straw, and I'm just going to blow into this straw. And hopefully you can see that the lime water is starting to go cloudy. This is because the lime water is calcium hydroxide. As we add the carbon dioxide into it, it turns into calcium carbonate, which is the cloudy precipitate that you can see.
Okay. So in this way, you can check the presence for, you can say, carbon dioxide, and ultimately, now you have question number two. Many chemical reactions occur in the atmosphere. The pie chart shows the relative amounts of some gases in air. Label the pie chart with the name of the gas that make up most of the air. Most of the air. So obviously it would be nitrogen. Am I right? Yes or no?
Yeah.
Good. What is the approximate percentage of oxygen in air placed across in one box?
Uh,
Percentage of oxygen, they are going to ask.
21.
21 is not present in this, so obviously this would be 20. Am I right?
Yeah.
Good. Use words from the box to complete the sentence. Above some of the other gases in air, each word may be used once more than once or not at all. One of the gas, one of the gases in air is argon. It's called a noble gas because it is very, very what?
Uh,
Very what?
is it unreactive, inert?
Ex exactly. It's very unreactive.
Can we say inert?
Exactly. Inert. But they are asking in the box.
Yeah.
Unreactive.
The percentage of water vapor in the air varies with weather. Sir, the next one's water vapor.
Uh, exactly. Water vapor. Okay. Rainwater is naturally slightly acidic because the carbon dioxide dissolves in it. Okay. So the word equation for the reaction is shown. Okay. Okay. Identify the acid form when sulfur dioxide reacts with water. When sulfur dioxide reacts with water. So when SO2 is going to react with water, what do you think? What would be the product?
Um, SO H2SO4.
SO3,
Oh, okay.
two oxygen and one oxygen. So total three oxygen. Can you name it? Can you name it?
From acid rain.
Can you
Nit
name this acid?
oh, hydrogen sulfide or
No, man. It's sulfurous acid.
uh, sorry?
It's sulfurous acid. If it would be H2SO4, that would be sulfuric acid. That would be sulfuric acid. There is a difference between sulfurous and sulfuric. Are you getting my point?
Yeah. Sorry,
So
sir. I've never heard that.
identify another pollutant gas that forms acid rain.
Nitrogen something or
So
something.
it would be NOx. Something means it may be NO1 and NO2, right? So it's NOx. X equal to any number. So that's called NOx. Any oxide of nitrogen. Am I right? Okay. State two
Okay.
problems caused by you can also write nitrogen oxide. Okay. State the two problems caused by acid rain.
Okay.
So
Um, from plane fuel when planes burn fuel, or when
you can say that easier thing is that uh, marine life marine life is damaged, or you can say the acid rain can damage the marine life. Okay. And you can say that uh, rusting of iron, rusting of iron, rusting of iron. Okay.
yeah.
When magnesium is burned in air, okay, it reacts with oxygen to form magnesium oxide. A class of students investigated the relation between the mass of magnesium burned. Okay. Why is it necessary to lift the to lift the lid from time to time while heating. Like let's suppose it's going to be heated in the crucible. Crucible is a substance, basically is the apparatus which is made of the material which is a good heat resistant. Because when you are going to heat any metal, obviously you are going to provide strong heating. If you are going to take any other glass beaker, it may damage, it may crack. So crucible is the special one that can be used for this purpose. And they are saying that weigh a crucible and lid, place the magnesium ribbon in the crucible, replace the lid and reweigh. Heat the crucible as shown in the diagram until the magnesium burns. So what? So they are saying lift the lid from time to time until there is no sign of further reaction. Allow the crucible and lid to cool and reweigh. Repeat the heating, cooling, and reweighing until two consecutive masses are the same. Calculate the mass of magnesium oxide formed. But they are asking it is why it is necessary to lift the lid from time to time while heating. Good question. It's a good concept.
Uh, to live all time for heating, so the gas doesn't get trapped in it. So the pressure of the gas is not too much inside. Okay?
The thing is that the thing is that when you have uh, any metal and it's going to react with oxygen, so ultimately its oxide would be formed. But the thing is that if you are going to have a lid on that container, that is crucible in this case, okay, so so there should be oxygen. So if you are going to remove the lid, it means that you're going to allow the oxygen to react with this metal. If there is no any oxygen, so how you can expect that your oxide would be formed and magnesium is going to burn? So if you are going to remove the lid, so you can write that to allow to allow the air, okay, to allow the air to come into contact with the magnesium metal, with the magnesium, okay, metal for a chemical reaction.
Okay.
Why it is necessary to repeat the heating until two consecutive masses are the same?
Um, why is it necessary to repeat the heating until two consecutive masses are the same?
Hmm?
Um, okay, wait, let me think. To repeat. Is it so that wait, no. To allow,
When you are going to reweigh your container, okay,
yeah.
so basically, the thing is that to to make sure all the magnesium has reacted or not, so you have to reweigh, you have to repeat your experiment. you know uh, what you are doing in this experiment, you are going to calculate the mass of magnesium oxide formed. If the magnesium is not reacted completely, so how can you calculate the mass of its oxide? So to calculate the mass of your magnesium oxide, so it's mandatory to react magnesium completely. But how can you confirm that magnesium is fully reacted? So what you have to do, you have to just burn it, take initial reading and final reading. Just you have to note it down on your notebook, and then again start heating to this magnesium, and then reweigh it, then take initial and final reading, then just reweigh, just repeat the experiment, start heating to this metal, and then just take initial and final reading. Do the same thing until you can get the same readings. When you would be getting the same readings, like the mass is not changing so far, the mass is not changing, it confirms that the magnesium is finished. Magnesium is finished. That's the reason the mass is not changing. So this is why we are going to take the two consecutive masses, and the two consecutive masses are the same. So they have given you the information. They are saying that the consecutive masses are the same. It means that it is making sure that all the magnesium has reacted. Are you getting my point?
Yeah.
Good. So to make sure all the magnesium has reacted, so no more oxide is formed. So no more oxide is formed. That's the reason you're going to heat frequently, okay, and take your reading. State how the mass of magnesium oxide formed can be calculated for the readings obtained.
Um.
Mass of magnesium oxide formed. Calculate how the mass of magnesium oxide formed can be calculated from the readings obtained.
Yeah. Oh, okay. Okay. So show up. Can you go back up? Oh. Oh, where are the readings? Oh, the readings are down below, right? Can you scroll back down? I think the readings were below. Okay. How can the results be? Wait, what was the question? The mass of magnesium. Okay, so the mass of magnesium oxide. But yeah, we just have it in the table, no?
Basically, uh, this is the magnesium oxide. Okay, this
Yeah.
is your magnesium oxide. So what you have to do, first take your initial reading in which there would be crucible, there would be lid, and there would be magnesium oxide. Then burn it, and then take your final reading. Take your final reading, okay. But the thing is that now you have to subtract the mass of this crucible and this lid to have the mass of this oxide. To have the mass of this oxide means that you are supposed to subtract the mass of your crucible, and the magnesium oxide. Subtract, going to subtract it from the mass of crucible only. If you are going to do this, you would be having the mass of magnesium oxide. Total minus the mass of crucible would give you the mass of magnesium oxide in simple. Are you getting this?
Yeah.
Okay. So now they're going to ask to draw the graph, obviously. Then you have to draw the circle around the anomalous result. Okay. So I'm going to send you this file. You're supposed to draw the curve, okay? Okay?
Okay.
Okay.